Hello students, welcome to Power Classes. So today we are going to do the revision of 10th chapter, that is circles. But before going to the chapter topic, I just want to show you small revision of what is circle and all. So suppose this is a circle. So for every circle there will be a center. The point which is joining center to any one end of the corner of a circle is called radius, and the distance from the center to any point, like from this one or this one or this one or this one, any distance will be the same, and this is called radius of a circle. Okay, and if we join two radius the same line, then that is called diameter. So diameter, we can say that diameter equal to 2 into radius. It is double of radius. So diameter should be 180 degrees line, or it can be like this or any way, but it should be a straight line. And the total angle of a circle equal to 360 degrees. That is, I'm starting from here, and if I do a complete 360 degree circle, I will again stop here. So then the circle will become complete. For suppose this is center and this is another point. Suppose I am keeping a radius of r, and if I am doing 360 degree rotation from that point, then that forms a circle. Okay, so these things you need to consider when doing any sum with circle. That is, it should be having a center point, and the center point, the distance from center point to any end of the corner of circle is called radius, and the radius will be same from center to any point. Whereas double the radius is called diameter. Diameter equal to the 180 degree straight line. It can be like this or like this or like this. Completely. Okay. So let's move to the chapter topics. So what is our main topics of this chapter is with respect to secant as well as tangent. All the exercise and chapters are, sums are considering. So before that, let's consider this is a circle here, and let us draw a line which is just touching the circle. Okay, so the line which is just touching a circle will be called tangent. If a line is touching 2 points, it is intersecting 2 points, then it is called secant. Whereas it is not touching the circle, then it is called like a different line. It is a non-intersecting line. Okay, so let's see in this. We can say that PQ is a non-intersecting line because it is not even touching the circle and not even intersecting at any point. Whereas AB, as I mentioned, it is called secant because it is intersecting at 2 points. Whereas tangent, as I mentioned, it is touching only at 1 point. Like it is not intersecting or it is not bisecting a circle or anything. It is just touching the circle. Like if I have a common point for the tangent and the circle, it will only 1 point, that is x1 comma y1. Okay. The important point here is there is only one tangent to a circle at a point. Like for suppose, if this is a circle and if I want how many tangents are coming at this point, then it will be only one tangent. Okay, if I consider at this point, also there will be only one tangent, and it will be like this. Okay, so if they mention, like suppose in the circle I have provided you a point, and how many tangents can be passed from that point, it will be only one. Okay, for suppose if I say that there is a circle and the point is inside the circle, then how many tangents are possible? If a point is inside, then the number of tangents equal to 0, because as I mentioned, if I draw a line from this point, it will touch 2 points. But as per a condition, the tangents should touch only at 1 point. So number of tangents are 0. But if a point is outside, here if I keep, then the tangents are 2, because I can draw like this. So if a point is outside, number of tangents equal to 2. This you need to remember for fill in the blanks as well as for any concept wise theory. That is, if a point is on the circle, then the number of tangents are 1. If the point is inside the circle, the number of tangents are 0. Whereas if the point is outside the circle, number of tangents are 2, because from this point we can draw two lines which are touching the circle. Okay. So let's move to the other topic. Let's see a few questions now. So here you can see that there is a chord. Okay, before that, if a line is intersecting at 2 points of a circle, then this point is called secant, as well as the line is called a chord. Okay. So let's see in this example, there is a circle here. They have mentioned PQ is a chord. PQ. So this is a chord here, and they have mentioned the PQ as 8 centimeters. They have mentioned the radius of a circle is 5 centimeters. So here you can see this is a circle and center at O, and P and Q are the points on the circle, and the distance from O to Q and O to P will be radius, as I mentioned here. In a circle, if there is a center here, and from here if I join any point on the circle, it will be radius and it will be same. So here also you can see that P and Q are points on the circle, so OP and OQ will be same, and it will be equal to the radius, that is 5 centimeters. Okay, and then they have mentioned the tangents at P and Q. From T, as I mentioned, if a point is outside the circle, the number of tangents are 2. They're like this. Okay, so here the tangents are PT and QT. And they have mentioned that from tangents from P and Q are intersecting at T, find TP. So they're asking to find this distance. Okay, so for this, what are the conditions and how we should proceed? Let's see. So this can be done in two ways. So I'm just mentioning first method now, then I will mention the second method as well. So first, using Pythagoras theorem, let's consider this point, this triangle. Okay, the part is Pythagoras theorem says like hypotenuse square equal to sum of squares of other two sides. So let's consider R as a midpoint of PQ. Okay, so triangle POR is a right angle triangle here, and this is center, whereas P and Q are the tangent points, and R I am considering as a midpoint of PQ. Okay, so hypotenuse here is, we already know it is radius, it is 5, whereas bisecting PQ, so this should be 4. So by using Pythagoras theorem, 4 square plus R square equal to 5 square. So OR square, that is equal to 25 minus 16, that is OR equal to 3. So we got this value as 3. So this again will be 4 and this again will be 5. But what we want, this value. Okay, so for that, let's consider PTO and PRO triangles. PTO and PRO. So from the triangles chapter, we know that if two angles, corresponding angles are equal and the corresponding sides are ratios are equal, then those two triangles are similar. So let's consider that concept here, so that now we can figure out what is the length of PT. So for that, see here, any tangent, if it is touching a circle, then this angle will be 90 degrees. The same way, this triangle is also having 90 degrees. Okay, so one angle is same. There are two right angle triangles, so using similarity conditions, angle RPO and PTR. RPO and PTR are equal. Like how it is equal, let's see. Angle PTR plus angle TPR. PTR plus TPR. So I'm sorry, let's see here. Angle PTR plus TPR, TPR plus PTR. Okay, so angle this and this one. So if I consider this triangle, this angle and this angle summation is equal to 90 degrees, whereas OPR and TPR, OPR and TPR, sorry, yeah, these two angles is also 90 degrees. The total angle is 90. So this one and this one summation plus this one and this one summation are both equal to 90 degrees. So angle as TPR on both sides are same, I'm just cancelling it. So this I am giving it a result as PTR equal to OPR. PTR equal to OPR. So I'm saying this angle, if I give theta, then this angle is also theta. Okay. Also the condition PT by PO equal to RP by RO. TP by PO equal to RP by RO. So TP by PO is 5, which you already know, that is RP by RO. RP here it is 4, so 4 by 3. From this we can conclude that PT equal to 25 into 4 equal to 20 by 3. It's might be a bit confusing, but if you consider my similarity triangle chapter, then it will be easy to figure out this question. Okay, so it's like we're having two right angle triangles. So we're using similarity condition, that is the ratios of corresponding sides are equal. That is PT by, so that is PT by PO. So you can see this is the right angle triangle here. PT by PO is equal to RP by RO. RP by RO. So you can see this is a right angle triangle and this is also right angle. So ratios of hypotenuse, not hypotenuse, the opposite sides, PT by PO equal to, again this is a right angle triangle, so this ratio by this ratio will also be equal. So this way PT by PO equal to RP by RO, that is PT by 5 equal to RP 4 by 3, that is PT equal to 20 by 3. Okay, so let's see in the other scenario like how we can also solve this question. So let's consider PT as X and PR as Y. PT as X and PR as Y, this triangle. So if you consider this triangle, then the hypotenuse square, that is PT square equal to TR square plus PR square. So here let's consider the first question, that is PT as X, if I mentioned, then hypotenuse square equal to Y square plus 4 square. TR I am keeping it as Y, that is this one. This square, PT square equal to TR square plus 4 square. Considering this triangle PTR, this triangle if I consider, this is a right angle triangle, so hypotenuse square, that is X square equal to Y square plus 4 square. So let's keep it as 1. Let's consider other triangle, that is PTO. PTO, this triangle. If you consider this triangle, this is 90 degrees, so hypotenuse is this one, so that is Y plus 3. Y plus 3 whole square equal to X square plus 5 square. Y plus 3 whole square equal to X square plus 5 square. So solving this, considering this as 1, this as second, and subtracting 1 and 2, we will get X square minus X square will be cancelled, and minus 5 square, that is minus 25 equal to, here Y square plus 16 minus Y square minus 9 minus 2ab, that is 2 into 3 into 6, 2 into 3, that is 6y minus 9. So Y square also get cancelled, minus 25 equal to 7 minus 6y. 6y if you move right left side, then it will become positive. 7 plus 25, that is Y equal to 32 by 6, then is 16 by 3. So just replace Y value here in any of the equation. So I'm just replacing in the first equation, that is X square equal to Y square plus 16. So Y you can consider 16 by 3 whole square plus 16, then X square equal to 56 by 9 plus 16. Solving this two will get 400 by 9, that X equal to 20 by 3. So I suggest if you get confused with similarities of triangles, the better you use directly the Pythagoras theorem. That will be easy to solve. If you're confident on the similarity triangles and which ratios can be equal, then I suggest you go with this consideration. Okay, let's move to the other question. So here I have a circle and they mentioned the tangent QT equal to 24 centimeters, Q and T equal to 24, T distance from center equal to 25, that is this value they have mentioned as 25. Find the radius. They're asking to find this radius. This can be OQ or OP. They're asking to find this. So before that, as I mentioned, if a tangent is touching a circle, then the angle between them will be equal to 90 degrees. Okay, and also the condition is if tangent is cutting here, then this total angle will also be bisecting, that is equal, it will be divided into two halves. Okay, let's see what they're first asking to find. What they're asking to find this radius. Okay, so we know this is 25 and this is radius, that radius is not known, but tangent is known. Tangent is 24 when you need to find this. But as I mentioned, a tangent is touching a circle, then definitely this angle is equal to 90 degrees. Okay, so now consider angle OQT, this triangle. So this is right angle triangle here. So QT, the hypotenuse square equal to this square plus this square. So simply 25 square equal to r square plus 24 square. So simply just 25 square is 625 and 24 square 576. So r equal to root of 625 minus 576, which is equal to root of 49. The radius equal to 7 centimeters. We cannot consider radius as negative because it is a positive quantity. Okay. Now see another question. They have mentioned they are asking to find angle PTQ. PTQ. So this total angle they are asking us. For this, what I am doing is, I am considering triangle PQPT. QP. Okay, it's not QPT. So in the question they have mentioned this total angle is 110 degrees. So as I mentioned, from the if a point I am intersecting to the center, then this angle will be divided into two halves, that is 55 and 55. Okay, so if I consider triangle OPT, that is this triangle, as from the triangle chapter we know that sum of all three angles in a triangle is equal to 180 degrees. So this angle we know it is 90 and this angle we know it is 55. So angle 90 plus 55 plus OTP, that is this angle theta by 2 if we consider, then all three summation will be equal to 180 degrees. So 90 plus 55 plus OTP equal to 180. So OTP equal to 180 minus 90 minus 55, which is equal to 35 degrees. But they are asking to find angle PTQ, that is total angle. So it will be twice of this, so which is equal to 70 degrees. Okay, so if let's me revise with small topic here. So if there is a circle here and if there is a point and two tangents are touching the circle, and suppose this is a center, and if I draw a line from here to this point, so these angles are 90, and suppose this angle is total angle is theta, then small angle is theta by 2 and theta by 2. Same way this is also theta 1 by 2 and this is theta 1 by 2, whereas total angle is theta 1. Okay, so this angle is also getting bisected. At the same time this angle is also getting bisected, whereas these two angles are 90 degrees. So if any question, if they are asking to find this one or this one or this one, this is already radius, so both are same. So these two are similar triangles. If you want, you can also consider that concept, that angle is same and two sides are also same, so those two are congruent triangles. Okay, angle, side and other side. SAS property, I can say that these two triangles are congruent. Okay, so if any questions are coming with respect to these two triangles, then you can simply consider these 3 points. Angle is 90, one side is radius, other side is the tangents, so both the tangents will be same. Okay, so this question is done. Let's move to the third question. Let's see this type of question, how we have to solve. So they mentioned two concentric circles. So what is concentric? Concentric in sense both triangles are circles are having same center. Okay, so two concentric circles of radius 5 and 3 are present. Find the length of chord of larger circle which touches a smaller circle. So if you consider the circle diagram, it will be like this. There is a one center and two circles. Okay, and they are asking to find the length of chord which of a larger circle which touches a smaller circle. So if I consider this line, that is SQ, this is a chord of larger circle and this is touching this inner circle. So you can simply conclude that this line is the tangent to this line, to this circle, because if a line is touching a circle, then definitely it is a tangent as per our first condition. like this. So if a line is touching the circle, then it is a tangent, and if a line is intersecting 2 points, then it is a secant, or if we can also say that it is a chord of the circle, chord in sense from this point to this point. So this is a chord to the outer circle, and both the circles are mentioned like this because I have mentioned that these two circles are concentric, that is having only same center. Okay, now they are asking to find this line, that is SQ length they are asking to find. So again similar concepts, that if a line is touching like this towards inner circle, then it's a tangent. The tangent property, angle is 90 degrees, 90 degrees. So consider this circle, this triangle. They have mentioned the outer circle radius as 5, so this is 5. Inner circle radius is 3, so this is 3. Now this can be figured out easily because this is a right angle triangle. Right angle triangle property, Pythagoras theorem, that is this hypotenuse square equal to sum of squares of other two sides. So 5 square is equal to 3 square plus PQ square. So now we find that PQ equal to 25 minus 9, that is root of 16, that is 4. So I found this value as 4. So as I mentioned, if a tangent is getting drawn, then definitely this triangle and this triangle also will be equal to congruent. So how they are getting congruent? First thing, both the triangles are having 90 degrees, angle 90. Second, both the triangles are having one a line, that is radius. So side radius of outer circle dimension, that if okay, and the other line is radius of inner circle. So side and angle are considering here. So as per SAS congruency, so both the triangles are congruent, so SP will be equal to PQ. This we already found, it is 4, so this also will be 4. The total length will be equal to 8 centimeters. So using SAS property, both that OSP and PQ are same, so SP equal to PQ equal to 4 centimeters, so chord length will be equal to 8 centimeters. So as we can consider that all the questions in this chapter are interrelated with respect to triangles chapter. Okay, so if anyone is coming new and starting with circles chapter, I suggest you to go and watch my 7th and 8th chapter, that is on triangles, where I can mention how to find Pythagoras theorem questions and how to solve what is SAS, what is ASA properties of congruency, what are similar triangles and what are their respective ratios and all. So that will be easy if you consider that chapter as considering first, and if you solve all the questions or remember at least the concepts, then all the questions of circles chapter can also be solved easily. Okay, so if you like the video, please like it. If you have any questions respect to doubts or anything, you can just comment in the section, or else you can also check my Telegram link, that is I have mentioned in the description. So you can join the group and ask for any questions so that you can solve and paste the solution there. And also please share for any CBSE students who is currently studying 10th class, so they can also get benefit from it. Thank you. Let's meet up with chapter number 11.